YouTube channel. Today we're solving Leetcode 2924, Find Champion 2. There are n teams numbered from 0 to n-1 in a tournament. Each team is also a node in a DAG. You are given an integer n and a 0-index 2D integer array edges of length m representing the DAG where edges of I equals ui, vi indicates that there's a directed edge from team ui to team vi in the graph. A directed edge from A to B in the graph means that team A is stronger than team B and team B is weaker than team A. Team A will be the champion of the tournament. If there is no team B that is stronger than team A, return the team that will be the champion of the tournament. If there is a unique champion, otherwise return -1. Oh my god, what is with these reading questions, man? Is this a coding platform or a kind of SAT reading comprehension preparation? Jesus Christ. Okay, so let's look at a basic example here. We have this graph. We have nodes 0, 1, and 2. So there's an edge from 0 to 1, which means that 0 is stronger than 1. And there's an edge from 1 to 2, which means that 1 is stronger than 2. So 2, obviously there's something stronger than it, so it cannot be the champion. Same with 1, because there's an edge meaning that 0 is stronger. That means that 0 must be the champion here, because there's no edge from any node into 0. And that's essentially how we want to approach this problem. All we're going to do is basically the following algorithm. So we're basically going to build a graph of sorts, and we're just going to count in degrees. And what is an in degree? Basically, it just means how many nodes have a path, have an edge between that node and another node. So basically, we know that for two nodes, A and B, if there's an edge from A to B, it means that A is stronger than B. So we're going to keep track of all of the nodes that are stronger than a given node. And then once we have all of that, we can basically find a node with 0 incoming edges, right? Because that will mean that actually this node is the champion because there's no node that's stronger than it. Now, if we actually read the example here, it says that we need to find a unique champion. So it could be the case that actually there are 2 nodes with 0 incoming edges, in which case we would just return -1. So this is really all we need to do. We're just going to store a count of all the incoming edges for a given node, counting them as we go along, incrementing by 1. And we'll go through the graph to traverse to find all the nodes with 0 incoming edges, and basically we'll just return the one that is the champion if it's there, if it's unique. Otherwise, we'll just return -1. So let's go now to the solution editor and actually type this one up. We are in the code editor. Let's now type this up. First thing we need to do is actually store our kind of graph here, or at least the count of the incoming edges. So let's define a variable here. So we're going to say in degrees, and this is going to equal to 0, and we're going to multiply it by n because we need to store for all n edges. So now what we want to do is we want to iterate through the edges here. So we're going to say for a, b in edges, what we're going to do is we're going to say that in degree, and we only want to count B because obviously A is stronger than B, and we just want to find the count for the nodes B. So basically, we want to just know which nodes have nothing stronger than them. So if we increment here, then obviously that will kind of remove it from the running of being a champion. So we basically count all of the in degrees for the B edge, which marks how many nodes are stronger than them. Now all we need to do is basically just try to find a champion. So we're going to say champion, and initially this is going to be -1. And remember that you can actually have more than one champion, in which case we actually want to return -1. So we need to keep track of all the nodes that actually have 0 as their in degree, because if there's more than one, then technically there is no champion. So we need to return -1. So we're going to say the champion count is just going to be 0. And then we want to basically just go through our graph here. So we're going to say for I in range of n, we basically want to say if the in degree for I equals to 0, then we're going to say that the champion count, we're going to increment that by 1, and we're going to say the champion, a candidate for the champion is now I because its in degree count is 0. So once we do that, we'll basically have found all of the champion counts and a candidate for the champion. So in this case, either we have a champion, we have more than one champion, or we just have there is no champion. So what we want to do is simply return the champion. We want to return the champion if the champ count is actually strictly equal to 1. Otherwise, we want to return -1. So if there was no champion or there's more than one champion, then obviously we just return -1. Otherwise, just return whatever the champion is. Cool, so let's run this, make sure it's all good. In degrees, it should be in degrees, right? In degrees, yeah, whoops, slight little yeah, this is what happens when you abbreviate. Okay, there we go, sorry. And should be accepted, cool. So, what is the time and space complexity? So obviously we need to go through all of the edges once, so that is going to be, let's see, big O of n for the time. We need to go through the edges one time to build kind of our graph. And then we also need to basically check all the champions. So we're just going to say this is, I guess, big O of m. So let's see, what is n and n here? So n equals number of nodes, and then m equals number of edges. So we need to traverse all of the nodes basically to find the final answer, and then we also need to traverse the number of edges. So that's kind of our time complexity there. So for the space complexity, obviously we end up storing all of the nodes in the in degrees. So this array is just going to have length n. So again, this is just going to be big O of n, where again n equals number of nodes. Cool, so that is how you solve this problem. Relatively straightforward graph problem. Luckily, don't actually have to do too much. Not sure why it's considered a medium, but it's probably more of an easy, but whatever, I'm not gonna argue with their assessment here. Relatively straightforward. Looks like it's gonna be a graph week this week on Leetcode, so hopefully you enjoyed the video. If you learned something, why not leave a like and a comment? Helps me out with the YouTube algorithm. Otherwise, subscribe for more content like this, and I'll see you in the next one. Bye.